Okay, weight is gonna be hard because this thing, which is just motors, like a light frame, a battery, that's about it. I mean, this already weighs 210 grams, and I need to be a pound or under, and a pound is 453 grams. This isn't quite half of the weight, it's a little under half of the weight, but there's no armor on it, which is heavy. There's no weapon system, which is heavy. Like, I was maybe considering for motors, those aren't the heaviest things, but it seems like it's going to be a tight mass budget. I mean, maybe the battery is a big chunk of the weight here. Still, something to watch out for. But you know, if I have to cut systems to make weight and finish it, that's fine. Two new things that are important related to the fact that I'm going to have a spinning weapon is I need to find the weapon motor and the weapon ESC, and I also need to build a test box now, because very dangerous to run a big spinning metal thing without it being protected and enclosed in a walled container that it can't get out of. So, more items to do. Things are looking pretty classic so far. Here's the frame for the drivetrain. You got the two walls. The wheels are gonna go in between, using shoulder bolts and bushings to let the wheels spin nicely and be solid. And then I think I'm going with two motor 4-wheel drive. So the motor's going to be in the middle here, and it's going to have kind of like this pulley thing going on, where this is going to spin and it's going to drive both wheels. And I'm thinking of using O-rings as my belts, essentially. This was just something that I've seen done before on another robot, and it seems simple enough. I like using the O-rings because they are apparently stretchy enough that I don't have to worry too much about tensioning. Because if I was using chains or belts, then I'd need this distance here to be just right, that I can get the belt around, but keep it tight. But I think the O-rings are going to be stretchy enough that there's a lot more flexibility in that. Next is going to be making the wheel parts that also have these ridges to do the belts. This is going to be a 3D printed part so far, and same with the wheels, and then I might cover them with something else that's grippier. I'm not super happy or confident that this 3D printed part is going to hold onto this shaft. That's why I made it so thick, to give it as much surface as possible. Like, I don't want the shaft to just rip through the 3D printed hole. I'm going to try to put set screws in here too. We'll see. Frame's going to be 3D printed. The rest of this stuff so far is just random McMaster parts. But it's coming together. And, you know, keeping track of the plan of making it symmetrical, so like my wheels are going to stick out on both sides equally. Found parts for the weapon motor and weapon ESC. I just stole from the Viper kit again. The Viper kit has like a vertical spinner add-on, and I just used that motor in ESC because it's basically what I'm using for everything else, so I know it will work nicely together. Here's kind of a weird idea. What if I made my weapon slower? So I'll put a big ol' pulley on the motor end, and then I'll spin a very small shaft on the weapon side. So I don't know, it's gonna be like a 5-to-1 gear ratio essentially. So my weapon's gonna be spinning 5 times slower than the motor, which is probably worse competitively, but it's maybe safer. And high torque is kind of cool because then it spins up quickly, and it also maybe has the potential to do some like pushing. Like if it's higher torque and like the other bot gets hit and then is like sitting on the weapon's not gonna be able to push the bot out of the way. But if, you know, I have 5 times as much torque as a standard weapon motor, then maybe, you know, I'll like push the bot up and, you know, keep doing stuff to them. Also, the slower the motor is moving, the more bite you actually get. And the way to put your weapon energy into their robot is you need lots of bite and lots of momentum. So by reducing speed, you actually gain bite. So it's not as bad as it seems to slow it down. I guess the main driving factor is it's safer if it's spinning like 5 times slower. It might not matter, maybe, you know, I don't know exactly what it is, but let's say tip speed's 100 miles an hour versus 500 miles an hour. Both of them are probably bad and dangerous. So I don't know if that's actually any safer, but it's an idea. I'm running into a little issue here. I think the robot is turning out quite large and therefore heavy. And kind of the driving reasoning for that is this weapon motor is kind of tall. And it needs to be centered and within the frame of the robot. I don't want it like sticking out the top or bottom. So that means that my frame needs to be taller than this, which means that my wheels need to be taller than the frame in order to have good ground clearance. That means they need to have a certain distance between each other in order to not touch the walls and then the pulley core and things like that. And that just, you know, expands it out this way, leading it to be somewhat large. So I'll see if there's anything I can do about that, and hopefully it stays underweight, but I am not sure. Drivetrain is pretty much done. I found a way to get some more space by making this section thinner. So now the wheels can be closer together and reduce the size overall. I also switched it to being made of like 4 main parts. So there's going to be a top plate, a bottom plate, and then these 2 drivetrain boxes. And then I started working out the weapon motor, doing pretty similar things to how the drive wheels work, except instead of driving a wheel, it's going to be driving the weapon up front. I think the next major thing though is I kind of started drivetrain first. So, you know, this overall structure was kind of thought out for the drivetrain here, but it wasn't thought out for the motors. So now I'm just having to add like mounting pieces sticking out of the frame like this, and it's not going to be strong enough. Like, I was thinking of doing something similar to this with the weapon itself, but then you get hit in the front and this is just going to crack off. So I think I have to rethink the like main structure of the frame to better support the weight and the forces of the weapon itself. So that might be like essentially another box like this, but in the middle here to support the weapon forces. Or I could make it as wide and use the same frame here. That's also an option, is make the weapon this wide. I'll have to see if there's space in this area to hold that weapon bar. But yeah, it's coming together. There's a lot of details that need to be done to optimize it, and I'm still worried about weight. So we'll see. I'm kind of mentally preparing myself to need to cut the front wheels off and just do the two back wheels, and then that'll save space and weight. But we'll see. I'm gonna finish with the way it's heading now, and still have to do the hinge wedge too, which is gonna be a lot. Another important thing on that is, before I was thinking like the wedge would be like free to pivot however far it wants, but I think bad things would happen if it can pivot like all the way this way, because then it will get stuck like this, so I won't have a wedge. Then if I flip upside down, I'm gonna get myself stuck. Or if it can go the other way, like let's say I get caught on something and it just kind of flips and gets stuck like this, now I'm done. So I'm gonna need to let it pivot enough to always be on the ground no matter my orientation, but limit how far I can go. But that's a ways away. Next is figuring out the weapon stuff. Okay, I think we need to take a step back with this because, all right, just did some rough weight estimations and it's already too heavy without including an actual weapon or like all of the bolts and hardware I have going on. So yeah, this isn't going to work out as it is. So I'm gonna have to do something significant that makes this smaller. I think the only way to have it include all these systems that I originally wanted and stay under weight is to just uniformly reduce the size of everything. But that includes like getting smaller motors, getting a lighter battery, and all of these components. And I think at this point that's off the table. I don't want to research electrical parts and reorder and test them. So I have to stick with these, which means that I'm gonna have to start cutting heavy systems in order to make the weight budget. I think there's 4 main heavy systems here. It's 4-wheel drive, the weapon, good armor, and the big wedge on a hinge. So I'm going to have to significantly reduce or get rid of some of those systems in order to make the correct weight. The thing that I'm most willing to get rid of, I think, is 4-wheel drive. I can go down to 2-wheel drive. After that, probably go to armor, and then if needed, I can not build a weapon or not include the wedge, but I really don't want to have to get to that point. And if after all of that I'm still not underweight, then I am not quite sure how people build robots with these components within this weight. But I know that they do, so I think cutting these things will eventually get me to the weight I need. And while I'm designing these next versions, I'm gonna have weight a lot more in mind. Like when I was designing the drivetrain, I was trying to give it like peak friction efficiency, but really I should just be thinking about how to do it with as few heavy pieces as possible. So yeah, I'll start making some different versions of this, cutting out some of those main heavy components and seeing what looks like will stay under a pound. I've done a few things. So this is the original. The next thing that I tried was this. So the idea here was if I am okay with different length belts, then I can stagger these motors here and make my width way shorter. And that part worked, but a robot this size has like no room for the rest of the things. Like the battery fits on its own, but I don't know where the receiver is going, and it's not fitting a weapon motor or anything else, so didn't spend too much time on that. And this was going to be two-wheel drive. The next thing I tried is over here, and this one's a bit further along now. The main change is two-wheel drive and wheels directly attached to motors. So I was avoiding this because I want to keep my expensive electrical parts as far away from contact with the other robots as possible. So like in this one, you know, force that hits this wheel isn't going to be transferred to this motor because they're separated by a belt here. Whereas if this wheel gets messed up, then it could, you know, torque this motor or bend the motor shaft or all kinds of things. But I'm gonna have to be okay with it like this, and I'm kind of safer guarded against it because I am gonna have armor around the wheel entirely. So it's gonna be somewhat difficult to even hit the wheel itself. So it's not perfect, but I think this is a sacrifice I have to make to stay underweight. Not having four wheels saves a lot of frame and weight that way. So yeah, let me go into the other changes. Weapon is still going to be belt driven. And again, that's so like when my weapon hits another weapon and suddenly stops, the force of that isn't going to be transferred back into the weapon motor. Like all that can really transfer between the two is torque. So if my weapon suddenly stops, then the motor's going to suddenly stop, but like the force of impact is not going to get transferred back to this motor, which is good because then it's less likely to just shatter my motor. This bot's a little taller because only way to really fit this battery in is vertically. I'm starting to think maybe I picked a large battery. Maybe I could have gotten away with a smaller one, but here we are. And then I've done some work on the weapon. So it will spin, and this is up in the air right now. It might change a bit. Let me actually, before I get into that, let's look at the weight budget again. So this is for the new robot, and I'm estimating a lot of things. All the red ones I'm not 100% sure on, and it's coming right under the 453 pounds, or 453 grams, which is 1 pound. This leaves like 20 grams in like miscellaneous bolts and stuff. That might be not quite enough. So it's pushing it, but it's looking a whole lot more possible than the other design was. So I'm gonna keep moving forward with this and hopefully staying underweight still. Here's just a quick visual of all three of them together, and you can see how the first one was significantly larger than the others. This one doesn't quite work out, but this new plan, I don't know, it's maybe 2/3 of the size. So definitely a noteworthy reduction. Let's take a closer look at this weapon here. So belt driven, or technically O-ring driven, over the side here. And then this whole thing is gonna rotate on this big old bolt running all the way through the frame. The reason it sticks out is I think I'm also gonna make this the pivot point for my wedge. That might create a very steep wedge, which isn't the best. So we'll see if it stays like that, but that's the thought right now. This block is gonna bolt into this pulley here, and then the actual impact point is these big sharp bolts sticking out. This is kind of like how the classic like beater bar kit works. I didn't want to just, buy a kit part. Like, I probably should. It'd be easier and more effective, but I'm just kind of making my own version of that. I'm going back and forth between if I'm going to try to machine these out of like aluminum. If I can find a way to do that, then that would be cool. Or maybe I have to 3D print them. 3D printing's easier, and it would make it lighter, which is good if I need it to be lighter, but bad if I can afford more weapon weight. So we'll see what I end up with. But yeah, then it's essentially these two pieces connected by more big long bolts, which make it strong and also heavy, which is good. It's going to be a really small weapon. Typical weapon diameters, I don't know exactly, but I've seen stuff like 60 millimeters or like 4 to 6 inches. What is mine? Mine's going to be, 34 millimeters, so it's quite small. It's not gonna pack the biggest punch, but that's okay. I just kind of wanted to have a weapon. I'm not too concerned if it's kind of weak. It's gonna spin real fast. I kind of wish I could spin it slower. I guess I could throttle it down, but anyway. That is that. So I think next, there's more to be done here, but I'm going to start figuring out this wedge thing, because that's the last major piece that I haven't touched at all. But yeah, coming together. I've made more progress on this. I think it's kind of at the point where all the systems are here, and it just needs the details now. But I've been thinking about maybe not doing a active weapon like this. You're not really encouraged to build an active weapon on your first robot because of how complicated and dangerous it is. It adds a whole nother system, so if I don't have to do it, it gets me to the table faster. It also means I don't have to build a test box anymore. I don't even need to order any more parts because I already own everything else. So there's a lot of reasons to not have a weapon. So I'm gonna spend some time heading that direction. And I think what I'll do is I'll go back more to this, try to do 4-wheel drive again, but without a weapon. And I'll keep this like hinge wedge because I think that's like the cool part of it. Like the symmetrical hinge wedge is the hook for the bot, so maybe it'll still be kind of exciting enough even though it doesn't have an active weapon. But yeah, 4-wheel drive, and I'll be able to make it a lot smaller if I don't need this whole weapon system up front. So it should be underweight. This is like, a thought out concept now. I can keep this in the back of my head, and we'll see which direction we go. If I do go the no active weapon route, I'll have to rethink the wedge a bit, because with a weapon, then the wedge's purpose is to get under the other bot and lift them up and into the weapon, and then the weapon does the winning. But without a weapon, then the wedge needs to be more of a control device. So I need it to kind of scoop up and let me push other robots around rather than just feed them into my weapon. A lot of Antweight arenas have a hole in the floor that opens up like halfway through the match or something, and if you can push another robot into there, then they lose. So that kind of becomes the main win condition for a bot without an active weapon. So I'll have to put some thought into making this wedge up front be good at directing other robots where I want them to go. So a little bit of a change. Another way to win with a wedge bot is the break your fist with my face strategy, which is basically have it so that when they hit you with their weapon, you are just a hard brick and you break their weapon. My original wedge wasn't designed to have that ability. It was going to be like durable, rubbery plastic, like it's probably going to be TPU, but that's not going to break any weapons. So if I want to go that route and I have the extra weight, I could make the wedge just a big hunk of metal so that when they slam their weapon into it, I have a chance of destroying their weapon. Here's version 4. It's a lot like version 1, but with no weapon. So 4-wheel drive, belt drive, hinge wedge. Yeah, just a solid brick with a wedge that can drive upside down and still get under you. It's a bit large, kind of like the first one, but no weapon, so it might still be under 1 pound. That's the next thing to check. So the details are missing from this, but I will see how much it weighs as it is right now and try to estimate if we're gonna make it under or not. This is looking very similar to the previous robot in weight. So that means that the frame and the armor of this is equal to the frame and the armor of the weapon of this. So yeah, I mean, it's possible. I might have to thin some things down, but it's in the realm of what is doable. Right now, my like frame and armor is almost 300 grams, which is like 75% of the weight of the robot. I don't know if that's normal. That seems very high. I'm sure if you have a weapon, then that number's lower, but for a control bot, is armor still 75% of the weight? I mean, why not? It's just gonna be a big old indestructible brick. So, yeah, that sounds a little fun. Sounds like a good way to not break your robot, which is cheaper. Like, you still might lose the fight if you just get kicked around a bunch, but if you can survive, then, you know, easy repairs and you just go to the next match. Like, that's not a bad place to be. I'm wondering if I should be more efficient with my armor mass distribution. Like right now, everything is essentially 4mm thick walls. So like everywhere is kind of equally strong, but maybe I should, you know, thin the top plate, thin the bottom plate, thin the back, and make, you know, this wedge super strong and the sides. I feel like that's probably better, assuming that I can avoid being hit in those other places. And if I drive well and if the drivetrain is good, then that should happen. I'll probably not go all in on the front, but I don't think I'm gonna make it totally even like this. I'll probably thin up the back and the top and the bottom and then make it a little thicker up front to just distribute that armor budget into the areas that I think are going to be hit more. And I don't know if I've talked about this yet, but in my head, this whole thing has been 3D printed. So as for material wise, I want to use as much TPU as I can because that's super durable, but it's flexible. So I have a feeling if I printed the whole thing out of TPU, it won't hold up structurally. So where I can't use TPU, the easy option is PTFE. I've printed with it before. It's reasonably strong, but it's not the best. Or I can try to figure out how to print nylon. And then, yeah, if I have extra weight, I was considering putting a metal sheet on the wedge. Or another option, this is probably for a future robot, is a metal sheet over TPU. So the metal is good at not being like cut or punctured, and then the TPU kind of shock mounts it. We'll see. That'll be probably not this robot. All right, I think this is the robot I'm going with. 4-wheel drive, wedge on a hinge so it can drive upside down. It's not as exciting as the one with the spinner, but I think it's the right move for a lot of different reasons. There's enough complexity going on here that I will be busy building this even though it doesn't have an active weapon. And I'll definitely learn a lot and then, be ready to do an active weapon on the next one. Something I kind of notice is all of the actual combat robot events that are near me, registration for those is happening like this month and next month. So I'm not going to be ready for that. And I'm hoping they run events more than once a year. That would be unfortunate to kind of just barely miss it this year and then have to wait a whole year. If that does happen though, I'll probably build the spinner version of this while I'm just waiting for competitions to exist. So that'll be something. Next is figuring out the connections between all of these parts. Basically how I have this lined out now is the two drive pods are separate parts, and then the base plate is this piece and these walls here, and then there's a top plate. Reason I did that mostly is for assembly and repair ease. For a while I was going to have the base plate be part of the driver pods, but then I realized I won't be able to put these motors in here without being able to separate these two halves. It's going to add weight having to fasten all these together, so it's a little bit of a concern of mine. Right now what I'm thinking for that is I'll put in these cutouts that I can fit in lock nuts, and then it's just going to, can't really see it, but it's going to bolt in through the panels and then tighten down on this. So then I'm not actually using the 3D printed pieces for the threads or anything. I can just hide a nut in there. So yeah, that's what I'll do next, go through and make all these attachments. Probably after that, some other small details to do, but then I will do a more thorough mass budget and see if we need to cut down anywhere after that. Just went through and made sure that this design meets my original requirements. There's a little more work to be done to make sure it follows the rules. Like I have to maybe have an indicator light, and then I definitely need the switch to be accessible so I can turn the robot on and off from the outside, and then wait. So more work to be done there, but I don't see anything about this design that makes me think I can't make it follow the rules. The rest are good. The hook is going to be like it just being really durable, and then the no difference between driving regular and upside down. And then active weapon, this one is a no, but it's in the semi requirements, so I can live with that. And then identity, I don't know what like the theming of this robot's gonna be yet, but I should be able to come up with something. So here we are. This might not be entirely accurate. I think I did this a few days ago, but we're somewhere around 90% of the way, or 90% of the time left, and I think we're making good pace. I expect we're going to be done well before this, but who knows, because things have taken me a long time in the past, just because I'll get busy with other stuff, and a few months go by like that. Okay, a few updates here. Let's start with how all these segments go together. So I kind of just followed through with what I said last time. It's held together by bolts and nuts going through each piece, and then a cutout to slot the nut in there. Easy to put on and off. A lot of bolts, kind of heavy, but it'll work. So the segments are going to be the two drive pods, and then now the top plate which includes the walls and a base plate. So I kind of flipped it. The main reason for that was when it was this way, I realized, I get under another bot and then their weapon is just gonna smash into this seam here and these bolts, and I didn't want it. That feels like a weaker spot. So if I'm driving, I should be upright most of the time. I'm starting upright. So now driving this way, they just hit like this solid piece. So I prefer that a little bit. The wheels, I was thinking about doing Lego wheels. A lot of people do that. I couldn't find a Lego wheel out there that was the exact size I wanted. So to make it easier for myself, I'll just do it with more O-rings. Hopefully these will be grippy enough. This is probably going to be something that gets improved in future versions, but this is just a quick thing that I can do for okay wheels for now. For the very front edge of the wedge here, I'm going to use a super thin plastic sheet. It's not going to be strong, but it's designed to just be like the lowest thing on the battlefield and just scoop right under other robots. And I was thinking a little bit about how I'm going to like push them around and control them, and I think the fact that my frame is kind of this H shape is going to help me out a bit, because they're going to sit in here and I'll have a little bit of control that way. So yeah, that's the design changes. I guess we can open it up and see what's going on here. So I added some structure to this base plate to hold my internal components. And also now I'm thinking the drive pods and the top and the wedge is going to be TPU, just super durable. And then the base plate is going to give it rigidity. I'm going to try to print it out of nylon. And if that doesn't work, I'll do like PETG or something. Yeah, that's all of the design stuff. I've also done a more detailed and accurate mass budget. This includes all of the parts, the hardware and everything like that. And then used CAD to find the volume and then just grab like the density and blah, 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 you get the weight. So right now it's coming out to 485 grams. 1 pound is 453 grams, so I'm a little over, but this is fine. I've colored these by how heavy they are. The main one is the wheels, and this is assuming 100% infill on this piece, but that's not how I'm gonna do it, so I could probably cut that in half. Even 50% infill, that cuts a lot of weight down. Now I have 12 grams remaining, so I'm under. And this, includes some buffer of like wires and things. It's on the edge still, but I think if I need to cut weight, I totally can. I did find out that my battery is oversized. So it's 3-cell, 11 volts. That's pretty common. But my battery is 850 milliamp hours. And usually robots of this size are like 300 or 450 milliamp hours. So my battery's like twice as big as it needs to be. Oh, yeah, so if I need to cut more weight, I could get another battery. Probably a good idea. My battery's physically large too, and it's taking up a lot of space in the robot. But this is looking pretty good so far. I've also done this budget sheet. So looking at all of the parts I still need to order. All these parts are coming from McMaster, by the way. So yeah, made a chart of those. It was coming out to like $100, which is more than I wanted to spend on like these random things. I used this to try to find places where I could use cheaper parts or use like the same part for multiple things, because like you see here, I need to order 100 of these because that's what it comes in, and I'm only using 2 of them. So that feels like a waste of $12. So the best I could do was, these are 10mm M2 bolts, and I also have, where are they, 12mm M2 bolts. So I'm just going to use these instead of these, and that works out in the CAD, so this $12 is free now. And then the other one was, I was using lock nuts because I didn't want things to vibrate apart, but those are quite expensive. So I just won't use knock nuts. I'll use regular ones, and that saves me $30. So yeah, I'm more happy with this number. I wish it was lower, but I can't combine parts like I did here anymore. So I'll just have to live with that. And then I'll have tons of extras. I guess if I build more and more of these projects, I'll slowly form a collection of nuts and bolts, and then it gets cheaper to just use stuff I already own. All right, this is something that I don't like about the current design, is all these metal bits sticking out the side. I don't really want like a spinner to come along and clip these. I probably don't have to be worried about them breaking these parts. Maybe this one, yes. I don't think I have to worry about them breaking these, but maybe I do. And even if they don't break the metal parts, it's just such a good bite point that they're gonna hit me and my bot's gonna go spiraling. So I don't want that to happen. But what can I even do about it? I could cut this shaft shorter. I don't really want to do that, but I might have to. I could sink these into the material. I don't want it to get too thin. I could like build a bubble of material around it, but that seems a little wasteful. I don't know. For this hinge, maybe I can find a way to have it lock in and pivot, but still be within this. Yeah, I'll have to do some messing around with that. Other things that I don't like, I'm a little worried about like horizontal spinners smashing into the side here. Like that's a really good place to grab on. I don't know. I don't want to spend too much time optimizing, so I'll throw a little thought into it and then just move on. Okay, for these I thought I would kind of half sink them into the material and then build a bubble around it. But I actually don't want to do that because I want this one to stick out, because this is what limits the motion of my pivot. So if I don't want to stick this one in shorter, and then if I stuck this one in shorter, I would need a shorter bolt, which means then I would have different size bolts for these two, and that means I would have to spend more money buying two different size bolts that I only need two of. So I'm just gonna have to build something around this. Or I guess I could sink this anyway and find a different way to lock the pivot. We'll see. So this one, here's the drive pod, and here's the wedge. I need it to pivot here. So that's why I have this double nut thing going on, so I can tighten it so that this distance is fixed without sandwiching the pivot to this frame here. So how do I do this better? I don't like it because this sticks way out and this is really thin. But I can't tighten this or else it doesn't pivot. Okay. Changes on the side. Made a little thing to protect that bolt. I'm just gonna cut this one off. Change this up. Now it's a bolt running through, and then there's going to be a nut on the inside, and I'll just keep it loose, and hopefully this doesn't slide off or break. I don't love it, but it's simple enough, and it sticks out way less. And then I put these angles here. It uses less material than when it was the full corner, and it also can kind of help corral other bots into the middle of my bot here. I'm gonna do some thinking on what's next. I feel like I want to start testing stuff, but I don't want to test something that I could have obviously known wasn't gonna work here. So I think I'm gonna go part by part and just quick check, do I think this could work? If yes, I'll buy it / 3D print it, and if no, I'll make some changes. Not trying to get it perfect right now, but I want to get it feasible. I want to, you know, build something, see what's wrong with it, and then come back to here. And even if it's not like 100% functioning, like I don't think I'm gonna buy everything. I want to prototype it, is kind of where I'm at. Okay, made some minor tweaks to fix things here and there. Kind of went through every part. Most of the changes I made were just like how tightly parts fit together. Needed to widen some tolerances there, and then added some pieces to the frame here so that the robot can't somehow, you know, fall on its back here and get stuck. Now it'll roll off one of the directions, and then same with on the side. Did the same angled edge here thing. It's looking pretty cool now. I don't know. It kind of reminds me of like a sports car, a big boxy sports car, but I like how it's turning out. So I'm gonna update the bill of materials and the mass budget, and after that I'll go ahead and start printing stuff, probably testing things out. Here's the new mass budget. I'm a bit over, mostly because I had typed in this with the decimal place in the wrong spot, so it was only 4 grams. But I think I'm gonna move forward with testing stuff. I'm not too worried about 26 grams. There's a lot of places where I can cut that down, and who knows like what other changes I find that I might need that might change this number anyways. So yeah, I'm gonna start printing stuff. I think I'm gonna start with the pulley core here. Small, easy piece, and I can check if it fits on the motor shaft kind of right away. So yeah.